Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Have you ever wondered if rocks could talk, what stories they might tell us about the world they inhabit? Well, in a way they do. Each mineral, each assemblage within a rock is a silent sensor of the environment in which it formed. They bear witness to geological events that occurred far before our time and will continue to do so long after we're gone. In this video, we will delve into the fascinating world of minerals. We'll explore how these ancient timekeepers can provide us with invaluable insights into our planet's past, present, and future. We'll witness the formation of diamonds and other precious minerals and learn how they can act as environmental sentries, monitoring changes in the world around them. So, buckle up and prepare to be amazed as we unravel the intricacies of these silent observers. Let us embark on this intriguing journey to understand how minerals act as silent observers of their surroundings. Each mineral holds within it a record of the conditions under which it formed. Just as a tree's rings tell a tale of its life, minerals too tell a story of the Earth's history. They are the silent witnesses of the past, the chronicles of the Earth's geological journey. Minerals are not formed randomly. Their formation is a meticulous process that depends on specific temperature and pressure conditions. Think of it as baking a cake. You need the right ingredients mixed in correct proportions, cooked at the right temperature for the perfect amount of time. Anything less or more, and the cake is ruined. Similarly, each mineral is the result of a precise recipe of temperature, pressure, and time. For instance, quartz, one of the most common minerals on Earth's surface, forms under relatively low pressure and temperature conditions. These conditions are typically found near the Earth's surface. On the other hand, minerals like garnet and ruby require higher pressures and temperatures, conditions found deeper within the Earth's crust. Now, how do we infer these conditions from the minerals themselves? Well, it's all about their structure and composition. Each mineral has a unique crystalline structure and a specific set of chemical ingredients. These structures and ingredients are like fingerprints, unique to each mineral. By studying these fingerprints, scientists can determine the conditions under which the mineral formed. For instance, the presence of certain trace elements in a mineral can indicate the temperature at which it formed. Similarly, the size and shape of the mineral's crystals can give clues about the pressure conditions. It's a bit like being a detective, piecing together clues to solve a mystery. Only here, the mystery is the history of our planet. This detective work is not just about the past, though. It also helps us understand the present and predict the future. By understanding how minerals formed in the past, we can predict how they might form in the future under different conditions. We can also use this knowledge to explore for new mineral deposits or to assess the potential impacts of climate change on mineral formation. Thus, each mineral is a time capsule preserving a snapshot of the Earth's history. Each mineral we study is a testament to the conditions that prevailed when it was formed, etching the saga of our planet into its very structure. Now you might wonder, how do we read these stories that minerals tell? Well, it's all about the tools of the trade. In the world of geology, we have a number of methods to study these telltale minerals. Let's dive into some of these methods, shall we? First up, we have X-ray diffraction, or XRD. This technique might sound like something out of a science fiction movie, but it's a mainstay in the mineralogist's toolkit. XRD involves directing X-rays at a mineral and then observing the way these rays are deflected. The patterns of diffraction can tell us a lot about the atomic structure of the mineral, which in turn provides information about its formation conditions. Next, we have the electron microprobe. This nifty piece of equipment uses a focused beam of electrons to analyze the mineral's composition. As these electrons interact with the mineral, they dislodge other electrons from the atoms within, causing the atom to emit X-rays. The energy of these X-rays is unique to each element, allowing us to determine the mineral's elemental composition. These methods, along with others, help us to read the life history of a mineral. They reveal not only what the mineral is made of, but also how it formed. By studying variations in mineral compositions, we can infer changes in the conditions under which they formed. This might include variations in temperature, pressure, or the presence of certain elements. It's a bit like being a detective, piecing together clues to solve a mystery. Only in this case, the mystery spans billions of years and the clues are locked away in tiny mineral grains. But with the right tools and a keen eye, we can decipher these clues and read the stories they tell. So, while minerals might seem inanimate and unchanging, they're actually dynamic and full of information. Each one is a tiny time capsule, preserving a snapshot of the Earth's past. With these tools, we can unlock the secrets that minerals have been holding for millennia. Let's take the example of diamonds, those coveted gems that are more than just symbols of love. Diamonds, the hardest known natural material, are truly fascinating. They are formed in the mantle, the layer between the Earth's crust and core, under conditions of intense pressure and heat, typically at depths of about 100 to 150 miles. Imagine for a moment the intense pressure, which is about 50,000 times greater than that at the Earth's surface, and temperatures soaring over 1,300 degrees Celsius. It's under these extreme conditions that carbon atoms bond together to form a unique crystal structure, the diamond. Now, diamonds don't just appear in your nearest jewelry store, they undertake a remarkable journey from the mantle to the surface of the Earth. This journey occurs during violent volcanic eruptions, specifically those of a rare and powerful kind known as kimberlite eruptions. The diamonds are brought up to the surface in a special type of rock called kimberlite, named after the town of Kimberley in South Africa where these eruptions were first identified. What's truly remarkable about diamonds is that they can reveal a wealth of information about conditions deep within the Earth. Inclusions, or tiny fragments of other materials trapped within a diamond, are like time capsules. They can tell us about the composition, temperature, and pressure deep within the Earth's mantle at the time the diamond formed. This information is invaluable to geologists, helping us to understand the Earth's interior, a place we can't directly observe. And let's not forget diamonds also play a crucial role in various industrial applications thanks to their extraordinary hardness. They're used in drilling, cutting, and grinding tools. So, while they may be a symbol of love and luxury, diamonds also serve a much larger purpose. So diamonds truly are a geologist's best friend, providing insights into parts of the Earth we can't directly observe. Minerals, then, are not just inanimate objects, but active participants in the Earth's story. They are the chroniclers of our planet's past, the guardians of its present, and the harbingers of its future. They are our silent sentries, ever watchful, ever vigilant, ever ready to tell their tale. You see, minerals are far more than mere rocks. They are environmental sensors, each one a reflection of the conditions in which it formed. Their existence, their composition, their structure, all bear witness to the ambient environment at the time of their formation. It's as if they've bottled up a piece of the Earth's history and held onto it, waiting for someone to come along and read their story. Like the black box of an airplane, minerals record the events around them. They capture the pressure, the temperature, the chemical conditions of their surroundings. A diamond, for instance, speaks of great depths and immense pressure. A quartz crystal, on the other hand, tells a tale of cooler conditions closer to the Earth's surface. Every mineral has a story to tell. A story of fire and ice, of mountains rising and valleys forming, of continents colliding and oceans receding. They are the scribes of the Earth, writing its history in a language we are only just beginning to understand. In this video, we've ventured into the unseen world of minerals. We've explored their formation, their structure, and their role as timekeepers of the Earth. We've seen how they act as sensors, recording the conditions of their formation, and hence serving as a window into the Earth's past. But minerals are not just recorders of the past, they are also indicators of the present and predictors of the future. They can tell us about the health of our environment, about the state of our soils, our water, our air. They can alert us to changes, to shifts, to potential dangers. Next time you pick up a pebble, remember you're holding a piece of the Earth's history in your hand. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon and stay curious for new uploads.